A telescope that can detect Earth-like planets from among billions of stars. Its giant mirror is so huge that they have to cobble 492 mirrors to give it a shape. With a height of a 20-story building weighing 1,500 tons, it will be a brilliant feat of telescope engineering, exploring the universe for several decades to come. Circa 1600, people believed in the entire universe, Earth is the only planet that has life. Therefore, it was special. An Italian, Giordano Bruno, was skeptical about this claim. He proclaimed that there may be other planets out there harboring life. It's just that we do not know about them. You would not believe that Bruno was punished to have a view against the popular doctrine. He was burnt alive for that. Wish Bruno had lived today. Astronomers of 5 countries, India, Japan, America, China and Canada, have come together to construct a telescope whose main aim is to find next Earths in space.
इस परियोजना में जो लीडिंग इंस्टीट्यूट्स एस्ट्रोनॉमी के हैं, फॉर एग्जांपल आईआईए बैंगलोर, एरीज नैनीताल और आईयू का पुणे, वो इसमें प्रमुख भूमिका में हैं। बहुत सारे नए स्टूडेंट्स और नए फैकल्टीज़, इंजीनियर्स को इसमें इन्वॉल्व किया गया है। हमारा ये भी प्रस्ताव है कि दूसरे अन्य रिसर्च इंस्टीट्यूट्स और विश्वविद्यालय भारत में इस परियोजना में आगे काम करें।
It will be a 30-meter diameter telescope, 3 times larger than the largest telescope of today. So big that only 3 glasses of this size will fill an entire football field. We are heading to the hills of Eastern Ghats in Tamil Nadu. Far off from urban lights, these hills provide one of the cleanest skies for observation in India. This complex is also a home to the largest telescope in India, named after the famous Indian astronomer Venu Bappu. It is a monolithic telescope, which means the primary glass of the telescope is just one big mirror. The larger the mirror, the more light it can gather. The diameter of this mirror is 2.3 meters or 7.5 feet approximately. Once, this telescope was counted amongst the largest telescopes in Asia. The last 2 decades have witnessed a boom in the size of the telescopes. Many countries have already built telescopes of 8 and 10 meters. The next attempt is now to realize a challenging dream: a telescope with a mirror of 30-meter diameter. Why do astronomers want to build such a colossal structure? Indian Institute of Astrophysics, Bengaluru. Optical Instrumentation Lab.
This is a 50-inch diameter spherical mirror. This is an f1.45, very short f ratio, which is very difficult to fabricate here. This particular mirror was fabricated in order to test the convex secondary of the Venu-Bapu telescope.
A mirror is the most crucial part of a telescope. It requires careful grinding and polishing. The 2.3-meter diameter mirror of the Venu-Bapu telescope was grounded in this lab.
A telescope, you can call it as a light bucket. It collects a lot of photons. So, bigger the telescope, more the number of photons it can collect, which will aid the eye in getting the finer and finer details of the sky.
Light is like a carrier. It carries information of the past. Telescope catches the light for us to decode the message. Light has a finite speed. It travels 3 lakh kilometers in a second. This finiteness of light reveals a new insight about the universe. The Moon is 4.5 lakh kilometers away from the Earth. Light takes 1.25 seconds to reach the Earth from the Moon, which means that we always witness Moon in the sky, as it existed 1.25 seconds ago. The number seems very small now. With the increase in distance in space, the information that light brings becomes more dramatic. From the Sun, light takes 8 minutes to reach the Earth. The Sun in the sky is the Sun that existed 8 minutes ago. The finiteness of the light sets our limit. Wherever we see in the sky, we see the past, not the present. A hazy dot in the sky. This is actually a galaxy, Andromeda, the closest neighbor to our Milky Way. It is situated 25 lakh light years away from the Earth, which means the light from it that we see today left Andromeda 25 lakh years ago, at a time when even our ancestors had not evolved on the Earth. The light coming from the deep past is so faint that to catch it, we need a telescope with a very large mirror.
As you can imagine, a larger telescope mirror can collect more light, which means you can see objects which are much fainter in the sky using such a telescope. So when you want to look at objects which are very far away, they are typically very faint also. If you want to study such objects, you need very large telescopes. The second reason is if you want to see fine details of an object in the sky, even if you are studying a nearby object like a planet in our solar system. And if you want to study it in great detail, or a galaxy and the components of the galaxy in great detail, you need a big telescope to resolve the fine details.
$13 billion years ago, our universe began to expand. This expansion is called the Big Bang. The light that began its journey 13 billion years ago must be very faint now. The 30-meter diameter mirror is fit to be able to collect this light. This old light will help us learn new things about the evolution of our solar system, stars, and galaxies. This giant telescope will also have a key role to unravel and solve few puzzles of our universe. One of the puzzles is about dark matter. It is a kind of matter that makes its presence felt but is invisible to us.
Okay, the universe as we understand today majorly comprises of what is called as the dark energy. Okay? So it's almost like 70% of the universe is this dark energy and 30% is matter. Now 70% of this 30% of matter is what we call as the dark matter. Basically this is matter from which there is no light emanating. The matter is there, its gravity is being felt, but then we are not seeing it. Okay, so this is generically called as the dark matter. But what is this dark matter actually composed of? So what is the 70% of matter in the universe actually composed of that we are not able to see? Okay, so this is something which is an interesting question which is still not answered.
The discovery of dark matter will give us a new insight about the composition of our universe. There are speculations that the dark matter is composed of new fundamental particles than the one we know of. The resolution of the 30-meter mirror will be very high. It will help us find Earth-like planets in the space.
Everybody asks, why we are so special on Earth? It is just sheer coincidence, alignment of our planets, or something else is there. So if it is just pure coincidence or just the way we are positioned from the sun or other planets here, the life existed here, or this is all conducive to the life, then in that case there is every possibility within the galaxy, because having so many stars like our own sun, there must be many systems like our own, and at least in one of the systems, there's always possibility. No? There's a probability, always exists the probability. So maybe one system like our own sun and our own Earth exists, and then in that life may be existing.
The mirror of a 30-meter diameter is the trump card of this telescope, and it will require a new breakthrough in design to assemble it. Traditionally, telescope mirror is grounded out of blank glass. For structural integrity, telescope makers have learned to maintain a proportion between the diameter and the thickness of the mirror. As the diameter increases, this classical proportion causes the weight of the mirror to jump high.
You see that 2.3 meter. So it's very difficult to have a 30 meter, something like this, in a single mirror. If you want to have a single mirror, it's going to be heavy, and when you want to move the entire thing, different places you have a different sort of thermal expansions, and then gravity, the sagging happens, and also logistic nightmare. How, when you make that one, how to even transport it.
30-meter mirror will require a completely new design perspective. In the Pacific Ocean, over Hawaii Islands. The highest peak of this island chain is called Mauna Kea. 13,000 feet above the sea level, Mauna Kea provides dry weather, clear sky and stable airflow. Therefore, it houses some of the largest telescopes in the world. Among these are a pair of unique telescopes known as Keck telescopes. They are the largest in the world. The mirror in Keck is not monolithic, rather made of separate pieces of mirrors put together. This design is called a segmented mirror telescope. Keck segments are hexagonal in shape. To achieve the 10-meter diameter of a Keck mirror, 36 such segments were combined. The advantage of a segmented mirror design is that it is possible to imagine larger sizes by joining smaller pieces. The 30-meter telescopes will follow Keck and will be a segmented mirror telescope, but much bigger and more complicated. It will be made of 492 mirror segments. It will also be housed on the peak of Mauna Kea. Avarsala Engineering, Bengaluru. On the workshop floor of the factory, an important part of the telescope is under production. It is called a segment support assembly, the basic structure that will hold the mirror segments in place.
These are all the parts which were manufactured for TMT project. So that is a segment support assembly. So 3 to 4 years back we received an order for manufacturing of moving frame. So this is a prototype of that moving frame, and those are all the parts for segment assembly. These are all the parts belongs to actuator assembly.
Avarsala is also busy fabricating dummy mirrors. They will be used to test the segment support assembly. Therefore, have to undergo rigorous testing.
This SSA project's one critical component is mirror segment. You can see that it is on our CMM. We need to measure accurately. So it is a challenge for us, for manufacturing or at the same time for inspection also. We put it on our surface table. We did some studies. We had a discussion with our team. How to measure it? How to measure it accurately? That is more important.
These hexagonal metal pieces are the replica of a mirror segment. The diagonal of the hexagon is 1.44 meters. When 492 such pieces will be put together, we will get a surface of 30-meter diameter. Indian scientists are playing an ambitious role in this global project. This particular lab has been set up to test each and every part that will be designed and manufactured in India. At the moment, scientists here are busy devising methods to test a critical component. It is called an actuator. The job of the actuator is to save the primary mirror from any vibrations.
When a wind is blowing, the wind pressure is not constant. It keeps on varying and it creates disturbances to the mirror. And since the wind loading is keep on varying, it has to work in opposite way to nullify these disturbances. So the other requirement, a very key requirement, is the vibration generated anywhere in big telescope structure, right? So not get transmitted to the mirror. Once mirror start, vibrating, even it is a few tens of nanometer, that will affect your image quality. And nanometer is very, very small number, right? So the mirror should not jitter, should not vibrate, and this actuator has to take care of.
Design-wise, a tiny horizontal gap is maintained between segments in the mirror. An ideal state for the segments is to be in one horizontal plane. Scientists talk of this state as the system is in phase. In reality, there may arise many situations that may affect the phase of the system. For this, every segment is attached with 6 edge sensors.
Sensor gives 2 signals. One is gap signal, other is the height signal. So we can know what is the gap between 2 segments, but this is not very useful because we are not going to change the gap. Gap will remain same, but it is height which is very important. Any change in the height will again degrade the image quality, and you have to instruct your actuator to get back the segment. And the important thing is that in India, we could very successfully prototype the sensors. So these sensors are done by one private company called Gold, Pondicherry.
Edge sensors detect the vertical movement between segments. Actuators work up and down to bring the segments back to the same plane. Every segment will have 3 actuators. The whole system will have roughly 2,500 edge sensors and 1,500 actuators. They will be controlled through a computer. Despite all the advances in design, the super telescope will face a classical obstacle. Unless it is overcome, the image from it will not be sharp. There is a similarity between a high-speed car race and observations from large telescopes. Why do stars twinkle? Look towards the back of the cars, where the exhaust gases are heating the air. Everything seems to be waving. The hot air disturbs the light waves while coming across. Our atmosphere has circulating air of various temperatures. As a light wave enters the atmosphere from the space, due to the temperature difference, it gets disturbed. As a consequence, its wavefront changes. We see this effect as stars twinkling. For astronomers, it causes blurring of the image on the telescope. A technology called adaptive optics is used to rectify atmospheric blurring. As the night falls, the sky of Monarchy Peak gets studded with laser beams coming out of telescopes. They are aimed in the sky astronomers want to observe. At a particular height, laser beams heat up air particles, forming an artificial star in the sky. Astronomers study the wavefront of this star. It gives them an idea of the amount of wavefront disturbance in the region. Now comes the job of a wonder mirror. Its surface can be changed easily. A wavefront opposite to the wavefront of the laser star is created on its surface. Opposite wavefronts cancel each other out. This helps them to rectify the disturbance. We get the light waves as they existed above the atmosphere. This technology is called adaptive optics. Keck telescope took these photographs of the Uranus some time ago. First image when adaptive optics of the telescope was turned off. Second image when adaptive optics was turned on. Adaptive optics makes the atmosphere redundant. You get as clear an image as you get in the space. For Indian scientists, the 30-meter telescope is a golden opportunity to participate in a world-class research. They will face the most cutting-edge intellectual problems of our time. The experience and technology will help India usher in a new era of astronomy. With a 30-meter diameter mirror, cutting-edge adaptive optics, TMT, will be the most powerful telescope humankind has ever built. From the search for exoplanets to the evolution of our universe, its contribution to our knowledge will be immense. We will witness the universe as never seen before.